Okay, right, so today we're going to learn something really important for integration. It's called integration by substitution. Now, that is probably maybe one of the most powerful tools to integrate. But really, in this level, we're going to work with, and what I'm saying, it's going to help us, or you're going to help you integrate really difficult stuff when you get to university. Now we actually, the level of question we're going to use it in, you don't even need it. You'll see what I mean. But it's just introducing it to it. So we want to integrate this thing. Okay, so we have something times something. And actually, that's exactly what we did last time. Okay, so what we said is that we've got some kind of function. Okay, and then this is going to be the derivative of the inside. You can see it because what's the derivative of x squared minus 4? Well, the derivative is 2x. So it's like we have a function, and then we're powering it, in this case, by power half. Yeah, this is the function, and this is the derivative. Okay, and we learn how to do it, you know, like you were calling it, Olivia. We start, we guess a solution. We said, okay, it's going to be x squared minus 4 to the power 3 halves, right? Because that was power half. And then we guess that, and then we say, let's do the derivative of that and see if it fits in. Maybe we need to multiply by constant. Now we're actually going to learn how to do it with substitution, which, as I said, going to make my life easier. You don't have to use it. You could carry on doing it like we did last time, but it is going to simplify your life possibly a little bit. And more importantly, as I said, when you get to university and we deal with much more difficult integrals, then you really will need that. So the idea is to say, okay, this is our function, x squared minus 4. So we're going to substitute. We're going to say u equal, I'll write it down. Yeah, I'll write it down here. U is equal to x squared minus 4. Just once you kind of think this is the function, this is the derivative of a function, then call that u. So say define a new variable. Okay, right? Now in this case, the next step is to find what's the derivative of u with respect to x. Okay, so you've got u and du to dx. So that's going to be simply 2x. Okay? Now what we're going to do, we're going to rewrite this integral, which we integrate with respect to x. Now we're going to write it as a function of u and integrate with respect to u, du. Okay? What does that mean? What does that mean? Okay? What is 2x? I basically want to get rid of x. That's what I want to have only u's. So what is 2x? Well, 2x is du times dx. What is square root of x squared minus 4? Oh, square root u, or u power half. And then I still have to write that dx. Now comes something that I can spend probably half an hour to explain why I can do it, but I'm not, because it's not really important for high school math. In university, you'll have to understand it. What do you reckon is du to dx times dx? What do you feel like you can do here?
I'm guessing it might just cancel, maybe.
Yeah, you can kind of cancel it, right? These two kind of cancel. So you end up having du. Yeah? So you can write down, okay, these two cancel, u power half du. Now, why we do that, I'm not going to answer. I'm not going to get into it. There's like a whole philosophical, mathematical discussion why you can do it. But we kind of do it, okay? Yeah, I can start talking about chain rule, but let's just leave it. Okay, it makes sense, isn't it? Okay, now this is the cool thing. Okay, I'm gonna rewrite it here. Okay, this is something that we know how to do very well. Yeah. So let's look at what's the main thing we went. We went from an integral in x, which is really difficult, to an integral in u, which is dead easy. So what will be the answer here? U to the power of?
Half of u plus minus half.
No, we're not doing derivative, so we're looking one up above. So half,
yeah, okay.
3 over 2, yeah?
Yeah.
Okay? And now we want to get, because if I do a derivative of that, the 3 over 2 will jump out.
Yeah.
So I need to divide it by 3 over 2, yeah? Or in other words, times it by 2 over 3. Okay, so as that comes out, that'll cancel. 3 over 2 times 2 over 3 is 1. And obviously I need to put a c. Okay? So I found the integral for u, but I can't stop here because the question was about x. So I need to put it back in x. Okay? But that's all. Sub in. Okay? So I'm going to write down 2 over 3. And instead of u, I'm going to write x squared minus 4 power 3 over 2 plus c. And that's it. Easy, isn't it? I'm just checking that we got it right here. It seems to be fine. Okay, pause. Okay, so this is our next integral. And we'll see things won't be as easy, but still pretty easy. What is going to be our u now? Just x minus 2. Okay? And then, yeah? Okay, now the next bit we need to find is du to dx, which is?
The x, but it's not, that's what I'm confused.
It's just 1, isn't it?
Yeah.
Du to dx is 1, which is not the x.
Yeah.
Okay, now, so what we need to do now, and sometime we'll have to do it. Yeah, okay, let's start, and then hopefully it will help us to figure out what to do. So we're going to rewrite it in terms of u. Let's leave this x for a second. The square root is just going to be the square root of u, right? U to the power of half, and we're going to have dx here. But as you notice, the x is not the du to dx. So we're a bit stuffed here. What you'll have to do sometime is to find out, because I want to know what x is in terms of u.
Yeah.
That's fine, I'll just use that. So yeah, so x is equal to u plus 2. Okay? u2. And then, okay, so we're going to write this one, u plus 2, we integrate it. And then the last thing we haven't done is what is the dx. The dx last time, if you remember, it got cancelled because we had du to dx. Here, we had du to dx. That thing here was the du to dx, it got cancelled with dx. So we don't know what dx is. Now, again, I'm going to ask, and I'm not really explaining, it's just working with your intuition. What do you reckon dx is equal to in terms of du? Looking at this equation, du to dx. Du to dx is equal 1. What is dx equal to? Not sure? Just play with that one. What could you do if that was a fraction? What is dx equal to?
What did you take down across to du?
Okay, we just timed it by dx. Okay. So we got du equal dx. This bit I'm actually going to give you a formal explanation, just if you don't mind. Okay? But it works out as if you can just work with them as if they're fractions. Look at this. If I'm looking at this formula, that was the how did we find du to dx? So it's a derivative of u with respect to x. Okay, we just differentiated this equation with respect to x. But if I want to find out what is dx is, I can just start with this. What is dx to du? Okay, that's actually I will explain it, but it's actually not going to help. What is dx to du? Looking at this equation, x is equal to u plus 2. What is dx to du? If I want to differentiate x, x is a function that depends on u.
Yeah.
So what will be the derivative of x with respect to u?
1.
1 as well. And then again, I can find out if I kind of multiply it by du, whatever, it's dx equal du. Okay? So in other words, that dx can be replaced with du, and now I've got an integral with no x's. That's what I'm trying to do. I'm trying to eliminate all the x's. Okay? So I'll just pause here. All right, so now we might be a little bit stuck, because how do I do that? I'll just pause, let you think a little bit about that. Okay, well done, Olivia. So you realize we just need to multiply them, okay? So u times u power half is u3 over 2. And then I will add 2u power half, all that du. And now it's just an integral of the sum. Well, an integral of the sum is the sum of the integral. So it's u3 over 2 du. This is 3. Plus integral of 2u half du. Okay? The first integral, it will be u to the power of 5 over 2. I just did 1 up, but then I need to multiply it by 2 over 5. And the second integral, u power 3 over 2. Now look at this, okay? When I differentiate that, I need to have a 2. So what must I multiply it by? I want to get rid of the 3 over 2. When I differentiate, the 3 over 2 will jump out. So I want to get rid of it, but I also want to end up with a 2. That's it, exactly. 4 over 3 is what you want to say. Okay, 4 over 3. Okay, so you can say 2 over 3 times 2, exactly, 4 over 3. And obviously we need to add a constant. I don't need to add a constant for each one of them, because a constant plus a constant is just a constant. We don't know what it is anyway. Okay, I'll pause here. Oh, well, we're not finished. We're not finished, of course. What do I need to do now? I don't want the answers in u's. I need to sub in the x, okay? So I'll write it down here. I just, instead of u, everywhere I have u, I'm going to write x minus 2. So it's 2 over 5 minus times x minus 2 power 5 over 2. Okay, and in our level, we can leave these things like that. We don't need to write it in like a nice way. 4 over 3 x minus 2 power 3 over 2 plus the c. I'm going to quickly check that we got it right. What did they do here? Yeah, it looks like all right. I don't know why they time these things together. I'm not sure what that is. Yeah, that's fine. I'll pause here. Okay, so our last one. The integral of this bit. Okay? What is our u going to be equal to?
Do you have to take it all out, or do you just leave it there?
I mean, maybe before that, let me rewrite it in more kind of friendly form. So
Yeah,
it's
do you have
x.
to do something?
I can do it before I do that, but maybe it helps you to see it now. So what is our u going to be?
X squared.
That's it. X squared plus 9. Okay? That's the thing that starts all the situation. Now, I'm not saying we're actually going to have to do it, and I think we're probably not. No, let's not do it. So what is du to dx? It's not exactly x.
It's not. It's 2x.
That's it. 2x. Okay? So imagine if this was like a y, dy to dx. No, it's just that normally we use a y equal or something. So you suddenly get us confused. You're right, it's 2x, okay? So we almost have that, but not exactly. But we can, that's easy. It's actually good we've done that. So, and one more thing, no, that's actually what we want. Okay, so what is x? X is not du to dx. It's half. Okay, I'll write it here. So x equal half du to dx. Okay, because why are we trying to do that? Because remember, we want to get rid of the x. We don't want x's there. Okay, so x is du to dx times half. This thing is not a problem. That's u to the power of half. Okay, and we'll keep the dx there. Okay, then comes this part. You get to cancel. Okay, again, it's not we're canceling things here. There is actually a lot of calculus going around and why we can do it. I'm not going to get into it. You know, if you'd like me, you can come and we'll chat about it. So what do I write here? All right, we're looking for the integral of u to the power of half divided by 2 du. Okay, so that's going to be u to the power of what?
Sorry, what?
What's there going to be the power of u when I integrate it?
1.5,
3 over 2. Okay, we want to end up with half. So what should be multiple here? I want to get rid of the 3, but I want to keep the half. So it's a third, right?
Yeah.
Can you see that? When the 3 over 2 jumps out, the 3 will cancel, the 2 will remain at the bottom, which is what I wanted to.
Gotcha.
Plus c. Okay? And then the last thing, we substitute. So 3 x squared plus 9, or we can just write it like this. X squared plus 9 divided by 3 plus c. Okay? Are we done?